welcome to a new tutorial series. Focused on Grasshopper plus Rhino, a bridge to Unreal Engine 5. Unreal Engine 5 has a lot of really interesting and cool things that were brought in new to the Unreal Engine 5 version, and I'm going to try and use that new functionality to our advantage. And while we're at it, we'll try to investigate how we can get our Grasshopper geometry into Unreal Engine 5. So today's tutorial, basically the end goal of today's tutorial is to have something like this. You saw that the scene was completely empty, and as I pressed the play button, the scene was populated with geometry that was made in Grasshopper. And the way we do this is through an Excel spreadsheet. So if this is something that interests you and that you want to learn how to do this, stay tuned and I'll teach you. So I guess the first thing to do is to actually open up Rhino and Grasshopper and do a script. And here I have prepared a very simple script, nothing too fancy, but I guess I'll guide you through it just so that we're on the same page and you understand how we can export information out of Grasshopper. So let's start. What I want to have is a grid of elements that are basically instances or copies of one another, right? So my initial element is just going to be a box, a mesh box, and you can make any kind of a mesh box you want, but in our case, just a second. In our case, I made a 10 by 10 by 10 box, and I centered it, so it's right in the middle. I lied, it's not. Let's move it down, minus 3. Minus 2.5, I think. Yeah, now it's right in the middle. Right? 10 by 10 by 10. By the way, the units that we're using are centimeters. That is what Unreal Engine 5 uses. So if you are drawing in millimeters or inches or whatever, just type in units. Go to model units, change this to centimeters, hit OK, and oops. Don't do that. Hit OK, and then you'll be drawing in centimeters. Okay, so box 10 by 10 by 10. Let's reference it in as a mesh. Right click, set one mesh, bam. That's easy. Also, let me do bifocals so that you can see the names of things. Right? And now we want a field in which this box will be copied, right? So I'm just going to probably create like a rectangle. I'm using my originally done script in the top as a reference, don't mind that. But a rectangle on a plane, like that. And our plane is going to be world XY, that's fine. We just start from 0, 0, 0. But our X and Y size, that needs to be, let's see what I used. Yeah, sure. So that needs to be 1,000 by 1,000, right? 10,000, I'm sorry. 10,000 by 10,000, which gives us 100 by 100 meters, right? Like that. And now I want to center this this rectangle right on the 0, 0, 0 point, so that the midpoint here is the midpoint here. So the way I'm going to do this is I'm actually going to move the initial plane to minus 5,000, minus 5,000, right? I think so. Let's try. So if we just say construct point, like that, the point coordinates are 0, 0, 0, right? So if I plug this in, nothing changes because our starting point was already 0, 0, 0. But then if I say 10,000 divided by // -2, I will not be changing this, so I'm using a panel. and connect that to X and to Y, now no matter how we change the slider, our rectangle is going to be centered. Okay, great. So we have that done. Then I am going to create a field inside of that rectangle, and I'll use spin force as a means of how to create like a force field inside of it. That's the easiest way of how to get like fancy kind of curvilinear rotational information, right? Fields. And basically what this asks of me are, where do we have the points or planes in this case? So where do we have these kind of spinners? So let me just double check what I did. I just populated it, right? Yeah. So I just populate 2D, populate this rectangle with, let's say, 6. Come on, 6 points. And those 6 points are going to be our points around which we get the nice little spinners, right? Is there a way of how I can show you how the field looks like? Let's see. Let's see. So out of this, we get multiple fields. As you can see, 6 points generated 6 fields. We need to make them kiss. We need to make them interact, right? So the way you make fields interact and affect each other is by using merge fields tool. That's it. Now we get the mathematical field out of here, and to get some form of information, I guess under vector, under field, you can get direction display, for instance. But that's still, yeah, that, there we go. That looks kind of ugly, doesn't it? I guess that looks kind of ugly. So let's do something else. Let us create display the tensor vectors of a field section. Okay, field section. Yeah, that's better. That's better. And the n is samples, so I can create like 5,000 more samples, like that. So see how these circles are not ideal, and then the kind of borders between them are very sharp. We need to fix that. And one way of how you fix that is by changing the radius of these and also changing the strength. So all of them right now have strength 1, so all of them will be spinning counterclockwise with the strength of 1. So what I want to do is for each of these 6 points, I want to create different strengths, either +1 or -1. So I'll do a random number, and the random number is going to be either 0 or 1. Bear with me so far. 0, 1. I change this to right click and change this to integer numbers so that it only spits out 0 or 1, and I will get 6 numbers, right? So now you can see that I get 1 0 0 1 0 0. Sure, I could change the seed if I wanted to, but this is fine. Then from this I will create a list. So // double click 0, enter 1, and don't press enter again, just click anywhere outside of the panel, right click and unselect, I guess, multiline data, so that it shows up something like so. So this is a list saying 0 and 1, right? And you can see the indices are also 0 and 1. I'll double click the list and I'll change 0 to -1, right? So we have -1 being in index 0 and 1 being index 1. So now with list item, I can easily take this list and using the random numbers, either 1 or 0, as my indices, I can get, what am I saying? Basically everywhere where you see 0, where we had 0, it was replaced by -1. That's about it, honestly, right? And that is our strength. So now I can feed this into strength immediately, and you can see that, yeah, for instance, this guy now spins clockwise and not counterclockwise. This one as well. Yay. Okay, so that is done. Then for the radius, I kind of want to do the same thing, right? But I guess I'll just create a random number for the radius. So I'm just gonna copy this, and here I'm just gonna type in a radius that I feel like is good. So if we're dealing with 10,000 across, I'll try doing like 3,000 to 5,000. And don't press enter, just click outside, connect. You'll get 6 numbers in between these and connect those to your radius. Yeah, there we go. So much smoother, much nicer. Let me check what number I actually used, what numbers I actually used here. Oh, much smaller. Okay. So let's do, actually let's do like very varying. Yeah, something like that. That might be cool. 500 to 5,000. All right, so we have this done. And now, as you can see, if I increase the count, can't really see it, can you? If I increase the count, it just keeps creating new whirlpools in our field. All right, don't need to see this anymore, because we will be creating a grid of points in our rectangle, and we will be placing the boxes on the grid of points, and we will be rotating and scaling the boxes according to whatever direction they should have according to the field. Yeah. So our rectangle, let me double check. Yeah, we just divide. Easy. Okay. We divide surface like so. And for now, I'll just use like 25 by 25 points, not more, right? And I will move my little mesh here. I'll move it onto each of these points, right? So my mesh is there, and I just move it, and I could kind of create a vector between 0, 0, 0 and each of these points. But honestly, if you just, as long as your initial geometry is at 0, 0, 0, you can just do this and it's gonna work, right? Because basically a point can be translated into vector because it has XYZ values either way. So now we have just very small boxes there. Some might say too small. Let me scale up the box now. Let's say 5 times. So now it's 50 by 50 by 50 box. A bit better. You can see more. All right. So we have a bunch of boxes and we have our little field. What I'm gonna do, and we have our points. Actually, let's flatten the point list. Don't forget to do this. Follow me. Right click, flatten, so that everything is in the same little list. And let's start messing around with them. So first of all, for each box, I need to evaluate what's the condition of the field there. You know, what's the direction, what's the strength. So to do that, we will use evaluate field tool, which asks us for field and for points. Easy. It gives us tensor and strength. Tensor is basically a vector, a direction, and strength is how strong the field is in there, right? So in terms of the tensor, what we could do is we could say that, okay, each of these boxes, wait, do we first scale or rotate? We first scale it. Gotcha. Okay, so let's deal with strength first, because there is fluctuating strength of the field. The closer you are to the spinny boy, the stronger the field is, right? So what we can do is we can scale, and I will use scale NU, non-uniform scale. And I'll take these boxes and I'm gonna scale them. Their base plane, so I'm gonna scale them around their new happy points, like that. And I'm only going to scale their X, I think. Let's double check. Yes, I'm only going to scale their X. So I could immediately say, okay, this strength seems nice. I'll just connect it to X, and technically it should work if we hide the correct things. You know, this box is definitely smaller than this box. It's more squished. But that's not what we want. We want this to be kind of translated properly. So I'm just going to create a multiplication for the strength, because the strength definitely goes between 0 and 1, right? Yeah, I think so, at least. We'll see. Okay, so in terms of multiplication, I'll just use, I have no idea, 66. Connect that. Yeah, that seems fine. They start connecting, right? But I feel like that's okay, because we will be rotating them. So you can see that in the middle of each vortex, the boxes are, like, the strength is very low, because eye of the storm, I guess. Anyway, that works. We have our scale geometry. Now it's time to rotate it. Rotate 3D. We're gonna rotate our scale geometry. We're going to say the center point of rotation is going to be around the points. That's easy. Long wire though. The axis of rotation, that's going to be Z. So we will start by rotating it in Z, I think. Do we do Z first? No, we do not. We do Y first. Okay, sure. So our axis of rotation is going to be Y. Like that. And you can see right now everything kind of rotates 90 degrees. That's a little bit boring. So we will rotate according to the tensor. So we need to get an angle out, right? This is a vector. And if we kind of just do another vector, for instance, unit X, and we measure the angle between our brand new vector and the unit X, we will get a nice little angle here in radians, of course, in radians. But this one waits for us to give it an angle in radians, so we just kind of give it. And we get a bunch of sticks doing their little dance. Right? Easy. Okay. And now, while here it's fun, but here it's still, in the top view, it's still, completely aligned. So that's because we were only scaling it in X and rotating it around the Y direction, right? So think of it, just think, scaling in X and then rotating, swiveling around Y. We never rotated around Z, right? So we never broke the Z axis. So I'm just gonna create another rotate 3D. Oops. Our initially rotated geometry is our new geometry, right? For rotation, so we just connect it like so. Our angle, since I'm lazy, I'm gonna reuse that same angle right here. And for the center point, of course, I will reuse the same, my grid, my initial grid, the divine surface output. And then by default, this is Z, but just so that we're on the same page, I will create unit Z and connect it there. So now it's twisting and turning in all of the different directions. Nice. Okay. We have our little our little script. Honestly, I don't think I need to do anything more. I do not. That is done. Now we need to talk. So this is basically one element being moved, rotated, or moved, scaled, and rotated, right? So the minimum amount of information that we need to rebuild this field that we have just created in Unreal Engine is by specifying what kind of mesh should be used. In this case, it's our little mesh box. Specifying what's the position, X, Y, Z, 3 numbers. Specifying what's the rotation or scale factor for X, for Y, and for Z. And also specifying what's the rotation, around X, around Y, around Z. So we have 9 variables and we have just a name, right? And that's exactly what I'm gonna do. So I'm going to create, and for this I really need to, I need to do this so that I remember what's what, right? So first of all, and we will be kind of saving all of that data in an Excel spreadsheet. So the first thing that we do is we create these blocks, I guess. Yeah, like we will create these funnels, I guess. Yeah, best way to explain it is funnels for information. Each funnel will have the name at the top of the list and then all of the numbers that follow. Right, so as you can see, the first one is very, very simple. It's just, now repeat after me, it's just / index, enter, that's the name, and then it's going to be just series of numbers. So for each box we give it a number. Series, how many boxes do we have? Well, it's easy to just do list length, measure list length to just get the amount of boxes, right? That's our little count, and we get 676 boxes, and for each of them we get a number, right? So what we do is we just merge this with this and just zoom in and click on the minus sign to get rid of that D3 once you have everything plugged in. And then also let's just flatten it, just to make sure that everything comes out, really cleanly. So index, and then it starts counting. Okay, that's our first one. And now the 9 variables, right? So let's see what I wrote here. X dash location, Y dash location, Z dash location. Okay, let's just do one X, / X dash location. Like that. We will use merge like that. And what will come into merge? A number, right? So just an empty number component, like so. Minimize that. There we go. Don't forget to flatten just to be on the safe side. And I believe you're good to go. Oh yes, one last thing is the output that we get. We want to get it not in one big list, but we want all of the outputs to be separated into their own little branch. So we right click on the index merge output right here and choose to graft. And we right click on the second merge output and we choose to grab that as well. Okay. That's X location. I'll copy, paste, copy, paste. That's going to be our Y location. And that is going to be our Z location. Okay. 3 numbers are waiting for us. So how do we get that? How do we get that information? Well, there are numerous ways. One way is to just get the coordinates of these points, right? Divide surface points, you just get the coordinates, you separate them out. The other one is to get the translation information, the transform information from the move. Since this one is more flexible, I guess I will show you how to do that. So transform data. That I will read as a text, like that. Right, so we get move, a bunch of text, move, and then spacebar, and then coordinates, right? Text. Then I will split, text split, I will split the text with dash dash spacebar. Enter. Never mind, spacebar, click outside. This is not an empty box. It contains a spacebar in here. Right? I press spacebar and I clicked outside. So what it does, it basically, you can see here, it divides up move and our coordinates into separate pieces. And I will just say list item, give me the dash dash 1, the second item, because we start counting from 0, don't forget. So 1 is our second item. Give me the second item from the list. So only the coordinates. We separated those out. Now, in terms of the coordinates, we need to get rid of... Oh, wait. Why does this... Where's my Z? It's only X and Y. Oh, that's because Z is 0, so it doesn't need to move it in Z, so it doesn't. To get over this, I will move our initial construct point for where we create the rectangle. For this Z, I will give like, I don't know, 3 meters. 3,000. No, wait, 3,000 is like 30 meters. Sorry, 300. Connect that to Z. There we go. Now this should be, yeah. Now we can see that our coordinates are actually with Z value. That's weird, but anyway. And what we can do is we can, first of all, we need to get rid of the brackets, the first one and the last one, right? So I'm going to, actually, let's go to sets text. Where was it? Characters, like that. I get all of the characters separated, and I'm going to remove the first and the last one. So I'll call index of the characters with dash dash 0 and -1. 0 is the first one, -1, since you kind of wrap back to the end, right? You go back in the indices, so you end up at the end. So that's the last, always the last index. Okay, so we initially what we did is we removed the, what's the word? We removed the brackets, and now I'm just going to I'm not gonna read this. Wait. Let's just use text join. Text join, like that, easy. We're back to normal, and now all we need to do is just text split again. Like that, with dash dash, comma, like that. Because you see how the coordinates are separated by the comma? We can split them by the comma. So now we have 0, 1, 2, 0, 1, 2. We have 3 items in each of the little list. And I can just do list item like that and get out the first item, which is going to be X, second item, which is going to be Y. You need to zoom in to do this. And third item, which is going to be Z. I'll flatten, and connect them to accordingly X, Y, Z coordinates. Done. That was text, kind of not manipulation. Yeah, I guess text manipulation. All right. So this was the hardest bit. For the scale, actually, I'm kind of lazy, so I'm just gonna borrow these 3, like that. Let's just disconnect. And let's just change it to scale dash X. Is it scale X? Yeah. Then scale dash y, easy, and scale dash z, also easy. And while we're at it, oops, copy paste again. We will use rot x. I assume that's what I used for rotate. Yes. Rot y and rot z. Okay, we have that. A lot of stuff, I know, but we'll get through this, I promise. Okay, so in terms of scale, our x actually gets a scale, which is this little number right here. Well, whatever we feed into the x input here is our scale, right? So that's our multiplication. We just yoink, connected there. But in terms of scale y and scale z, we don't have, we're not changing it. So all of those are just one, scale factor of 1 for each element. So I'm gonna do this quite rudimentary. I don't know if that's the correct word to use, whatever. I will just say repeat data. I'll say that data that needs to be repeated is number 1, and the length of how much it needs to be repeated is basically how many meshes we have. So again, list length. Like that, like that. This is basically a list with a lot of ones in it. 676 to be precise. And I just connect it to scale y and scale z. Now, for rotation x, we never rotated around x. We only rotated around y and around z, right? So our rotation x is going to be 0 degrees, or 0 degrees. So I'm going to just borrow this, or repeat data again. This time I'm going to repeat the number 0. And I'm just going to connect the list length to my length input here. Just like that. Okay, now for rotation y, that is going to be our little angle right here. Actually for both y and z. The problem is that Unreal Engine will wait for us to give it degrees, while here with in Rhino we have radians. So I'll just convert this to degrees, like that, and I'll connect the degrees to y and to z, like that. Okay, so now we have all of the information. It's time to get it all into one big happy family, right? Merge. First comes the index, then comes the location, and so on, right? Just like that. And D11 is not used, so I just minimize that. Okay, and now let's just check. Yep. Now if I look at this, this is how it looks like, how the data tree looks like. We actually want one line for each of the branches. So I'm just going to use, and the line needs to be separated by commas. I'll use text join, like this. And our joiner is going to be dash dash, comma, click, oh, never mind, dash dash, comma, enter. There we go. Look at it again. This is how it looks like. We flatten this now to get one little list out of this. And this is what we're going to be saving as our Excel file. So I'm going to right click to save this, to automatically keep saving it. I'm going to right click this, hit stream destination. So I'm streaming this panel, And I already have a few tests here, so I'm just gonna keep on going. I'll say test 5, or let's do YouTube box. Now that sounds weird. YouTube box Excel. There we go. That's fine. And don't click save just now, just yet. Save as type, we need to choose that is going to be CSV. That's the Excel spreadsheet. Like that. Hit save. Now it's being saved. And if you click on stream contents, now every time when you change something, it's automatically going to update the Excel file. So if I were to go to my animation testing, my Excel, open it up, this is how it looks like, right? Pretty neat Excel spreadsheet. Okay, great. So that's what we have. Now it's time to start working on the Unreal part of things. So in the Unreal Engine, let me just, let's actually exit this. Save. Let's wait for Unreal to catch up. There we go. And we launch Unreal 5, Unreal Engine 5, we launch it. It's gonna do its magic. Come on. There we go. And I honestly always prefer to start with everything as a game. And you just choose either first person or third person. So I'll choose third person. I'll choose maximum quality. It depends on what kind of computer you use. I'll enable ray tracing in mine. And that's basically it. This is like very, very rudimentary settings, right? So it's gonna be for desktop, not for mobile. And the quality preset, I mean, use maximum, even if you're on a laptop, and if you need to, you will be able to tune it down later, right? If it becomes too crispy. Project name, name your project anything you want, and choose where you're gonna save it and click create. I will not be creating a new project. I already have one. I just need to open it, and it's fresh. It's a fresh new project, trust me. So we will be looking at the same thing. My project is called Consider Subscribing, please. Like 80% of people who watch my videos are not subscribed. Anyway, this is what you get. If you press play, you can play in it, jump around and whatnot, and you know, third person game. We don't care about this, all of this, but I will not be deleting this. Instead, we will be just going to File, New Level, and choosing Basic Level. Just a basic level, right? I already have it here. This is what you will get. That is our basic level that we have created, right? So now for us to begin, we actually need to set up or import our Excel spreadsheet, right? So how do we do that? Well, it's a bit tricky to explain, but bear with me. So first of all, if you don't see the content browser, you can just use the content drawer and it's gonna open up, right? That's in the bottom right here. And this is where all of your files are, right? Where all of your files are located. So if you go to content folder, Here you'll see 3 folders: characters, level prototyping, and third person. I'll create a new one, right click anywhere, and just choose new folder. And I'll just name it my stuff. And get in here. Double click on it, you're here. So in the folder called my stuff, I need to create 2 things. First is I need to create a blueprint system for Unreal Engine to know what kind of Excel spreadsheet it should expect to get, right? So I'm going to right click and I'll choose blueprint class. No, sorry, that was my bad. We don't choose, we don't choose blueprint class. We go to blueprints here. By right clicking, we go to blueprints and we choose structure. It's gonna be right here. So we're creating a structure of how Excel spreadsheets are gonna be read. Structure. We call this GH import, for instance. GH import, double click on it, and it's gonna open up this window for us. So this is where we create all of the different inputs, not inputs, where we specify each of these rows that we have in our Excel spreadsheet, right? The index, the location, the scale, and the rotation. So we're gonna do exactly that in just a second. So index, out of all of these, the first one is not needed to be specified here because it's kind of built in. You need the numbering, right? But everything else needs to be specified. So I will just say, instead of this one thing, or in this case boolean, I'll just change its name to x-lock. By the way, it matters if you're using uppercase or lowercase. X location, and this is not gonna be a boolean, so I'll expand this and change this to float value. It's not gonna be an integer, it's float, right? Like that. And this is our first variable that we have created, right? Then I can add more, if I remember how. Oh, there it is in the top. Add more. It's automatically going to be set to float, so we won't need to do that anymore. But now we just write y location, y lock, then add variable z lock, then add variable, don't remember, scale x, scale y, scale z. Scale x. You just need to do this once. Scale y, scale z. And then rot x. Come on. Rot y. And finally rot z. Great. We have all of our variables. I'll just click save and close this. So you click save and you close. Bam, we're back to normal here, and this is our structure. So now it's gonna be very easy to import our Excel spreadsheet. You just drag and drop it in to the same folder as well. Drag and drop it in to wherever your structure is. Failed the import. What? Why? Apparently I can't have it opened, as it doesn't like it when I have it when I have the file opened up and I try to drag and drop it in. But now it's fine. Now I just drag and drop it in. It works. Data table options. So make sure that it's closed before you do anything. Import as data table. Yes, that is correct. Choose data table row type. And what kind of type is it? it's gonna be, where's our little gh import? There it is. This one. And we don't really need to do anything else. Apply. That's it. Here's our Excel spreadsheet. I double clicked on it, by the way, so I opened it up. Right? We have a bunch of information from Grasshopper in Unreal Engine 5. Now we need to be able to read it. Well, first things first, I also need to get the box in here. So I'm just going to go back into Rhino and I'm going to select my little box, do that, and export it. That's my element, right? That's getting copied, scaled, and rotated and whatnot. So I'm gonna export it as my, well, I already have a box, but box for YouTube. There we go, and we export it as either FBX. I use OBJ, honestly. Where is it? OBJ, QQQ, or let's not QQQ, let's do GH box. Save. Polygons, sure. Formatting. Well, sorry, I'm just double checking if, yeah, everything's fine. So default values, get that exported, go back to Unreal, get the box in here by just drag and dropping in the 3D object file into our folder. One thing when you're importing it, I would choose build nanite immediately, because we will need to choose it later. What nanite does, it basically makes it so that your geometry can be reduced in complexity the further it is away from the camera. It's a new feature. Well, we used to have LOD's level of details, but nanite is a new feature in Unreal Engine 5 and it works wonders. So just have that enabled, build nanite, everything else is whatever, import all. No smoothing group information was found, we don't care, we close that. We have our little box and even a diffuse map, sure. So our box is gonna be black. There is it. There it is, sorry. That's our box, and if I press play, I can run to it. I just dragged it, by the way. Yay, our little box. Okay. So we don't want it there. I'm just gonna delete it. But we have its material and we have the geometry. So now, how do we do this? Well, the trick is that we need to tell this particular level to read the Excel spreadsheet as the game starts, right? So once we click Start Game, it needs to read the spreadsheet, right? So the way we do this is if you go here in the top, you can open the blueprint. This is basically like Grasshopper scripts for different things. So the blueprint of the world or of the level, right? Let me double check if you can see it. Yes, you can. So click here and choose Open Level Blueprint, like that, right? This is basically the stuff that happens inside of your level, right? So as event begin play, as playing begins, right, it needs to extract the data from the Excel spreadsheet. So we're going to drag out of the output here and we'll type in get data table row names, right? First we get the names of this, of our little table. So I'm just going to click on select asset, and I'll click on the Excel spreadsheet here. So we're getting the names, right? And it's basically an array of names, right? So we need to create a for each loop to go through each of the name and ingest the data or take in the information, right? So I'm going to drag out of this and I'll say for each loop. I don't think it needs to be with a break, so it's just for each loop, like that, and I'll connect it. So output row names connects with array. There we go. Then we get the loop body and we get the array element. So what's it kind of keeps looping through the names like indices, then it goes through the X location, Y location, Z location, and so on, right? So this is what it gets, the names that it gets, right? So I'm gonna get the data according to the row, right? So drag out of loop body and say get data table row. Not names, just get data table row. Like that. Row name is our array element, and table, don't forget, it's still the YouTube body, or YouTube box, sorry. YouTube box Excel. That's our table. Okay? We get that. And basically the output is we need to now break it apart into separate outputs, right? So output row, I'll just say break gh import. Like that. We click on the small arrow, we get all of the outputs here. That's very nice. And we will use those outputs. So now all of the information is available to us once we click play. So we will use those. We don't need to do anything else here for now. I'll just click on compile here in the top. Can you see the compile? Please tell me you can see the compile. Yes, compile, save, close. Okay. Really nothing will change if I press play. All it does, it just reads the Excel spreadsheet, right? So when I press the play button, it just ingests the information but doesn't do anything with it. So now we actually need to do something with the info, right? And this is where we will create a blueprint, right? So I'm just gonna right click and choose blueprint class. And I'll, I believe it's actor component, right? An actor component is a reusable component that can be added by any actor. An actor is an object that can be placed. Don't remember this. I need to double check. It might just be an actor. Let's try with just an actor, and if it doesn't work, then I'll just delete this part of the video. So if you see this part of the video, that means actor worked. So actor class, like that. I'll call it element or elements, like that. And this is my little blueprint, right? This guy right here. So if I double click on it, like that, it opens up three, or not three, it opens it up, but it has three different tabs. The viewport tab, how it looks like, the construction script, and the event graph. We will not deal with the construction script, at least, will we? No, we won't. We will only deal with event graph. So what happens with the blueprint, and also how does it look like, you know, the look of it. And also what kind of geometry it basically has is also shown in the viewport. So right now we have just the root system. So I will add a static mesh. A static mesh, like that. You can just kind of have it named static mesh, that's fine. And for it, I will select it here. For it, and on the right hand side, I will choose what's the mesh that I want to use. So let's use GH box, that's our mesh, like that. I wonder why does it look like a brick here. Anyway, doesn't matter. So it's using now the GH box as our mesh with the diffuse 0 as its color. Great. I'm not really gonna change anything here, at least I don't think I will. Let me just quickly go through these to double check. No, all of these are fine. Okay, all of these are fine. So we will be dealing with the event graph instead. This is much more important, right? So as we begin the play, we need to be able to make a bunch of copies of our static mesh according to the Excel spreadsheet location, scale, and rotation information. So what I'm basically going to do is I'll create a bunch of variables here. So on the left hand side, let's add a variable by just clicking this plus icon like that. And I'll just choose I'm thinking we don't need it to have the same name, so I'm just going to do X location like that, and instead of boolean it is a float, and I'm going to change a few more settings of it. So it needs to be instance editable. I'm not going to explain that. And expose on spawn, also not going to explain that, but just make sure that you have it selected and you tick mark these two ticks. Okay, and let's right click on it and choose to duplicate, and this one is going to be Y location, and right click, duplicate again, Z location, and so on. So you keep doing this, duplicate. Just keep duplicating because you don't want to put down those tick marks over and over and over again, right? X scale, Y scale, Z scale, and lastly X rotation, Y rotation, Z rotation. Okay, we have all of these. Poof. That was tricky. Well, not really, but it was. By the way, if you see the eye closed here on the where I have my mouse, just make sure that all of the eyes are open so that you can access these variables from any blueprint. Event begin play. So play begins. What do? We set relative location for a static mesh, like that. Right? That is for our static mesh, and our location is going to be made out of a vector. So this is going to be make vector. I think it's just this one. Yeah, make vector. And we're going to drag and drop in the X location, like that. Drag and drop and choose to get X location. Drag and drop Y location, get Y location, drag and drop Z location. And just connect X, Y, and Z, like that. Okay, so this is gonna position it, right? Then after positioning, we will want to scale, right? So we drag out of here and we choose set relative scale 3D. And we can choose static mesh again, like that. So it asks us for vector again for scaling, right? So again, make vector, just like that. Start dragging in X scale, get Y scale, get Z scale, get X, Y, Z. Okay, so it's gonna be first moved, then scaled. And lastly, it's gonna be rotated, right? So we drag out set relative rotation static mesh, and see how this is not yellow while these two were. So this is not waiting for a vector, it's actually waiting for a rotator. So we need to drag out of here and choose make a rotator. There it is, make rotator. And guess what we do now? You guessed it. X rotation get, Y rotation get, Z rotation get. X, Y, and Z. We get them all. Okay, so this is done, right? We compile, we save, we close. Compile, save, close. Right? We press play and nothing happens. Why? Well, because right now the variables that are inside of our elements blueprint, these guys, and the variables, close, the variables that are inside of our level blueprint, they are different, they're not connected. So we need to connect them. And the way you do it is through the level blueprint. So we again expand this and go to open level blueprint. And here you will need to you will need to create a not a spawn. In the level blueprint, you will be spawning all of those elements, right? So all of those actors that we just created the blueprint for, you will be spawning in the level, right? In this blueprint. So for row found, if it finds a row, right, you create a spawn with a W, spawn actor from class, I believe. It should be from class. Spawn actor, right now it's set to none, but if I change class to elements, this one, elements, then you can see that it asks me for all of the information here. So I connect X to X, Y to Y, Z to Z, blah, blah, blah. Just like that. There we go. Easy. And lastly, spawn transform. That is where should it be spawned. So I will just drag out of here, make transform. Nope, not that one. Make transform, this one. And I'll just keep it at 0, 0, 0. Sure, that's fine. Compile, save, close that, press play. Hurrah! Works. Also, intersections work as well. So you bounce off of them. How cool is that? Okay, so now to actually, oops, my bad. Now to actually make it more interesting, let's create in Rhino. Let's make more of them. Right now we are using 25. Let's use 25 by 25. Let's use 50 by 50. More 100 by 100. Like that. Yeah. And I feel like we need to move them a bit higher up. So Z coordinate, I'll change this from 3 meters to 5 meters. Do you need to do anything now? No, not really. You go back to your Unreal Engine, you right click on the wherever the Excel spreadsheet is, YouTube box Excel, right click, click on re-import, press play. Wait a second. And here it is. It's a little bit dark, I know. It's gonna get hopefully brighter. Not really. It's not getting brighter. Oh shit. Fell off. But yeah, you can see all of the nice little boxes there. Okay, time to come on. Time to make it nice. So one last thing that I want to do before we end here is I want to replace the box with something else, right? So honestly here, we don't need to change anything. So I'll just disable the preview of that. But instead of this box, I will want to use a sub-D object, right? So let me log this and let's just create a sub-D box first. Sub-D tools, box, XYZ count 111, just a box yay big, wherever it is, there it is. Should probably unlock and just hide this instead. And now we work with sub-D. So I'll just probably just expand this, right? Like that. Like that. And we just kind of play around with this until we get something that's fun. Like that. Okay, these two. Can we do an inset on them? 10. 10 is not a, oh wait, that is not 10. That is 10. 10. Okay, 10 is a lot. 1. Sure. Bridge. We get a tube, sure. Let's make a cross. Yeah. Like that. Okay. Like that. Inset those. Let's say by 3. Then this moves in. This moves in. And this moves in. Okay, I don't know. Random. Very random. Completely random geometry. But might do the trick. And I'll just make, let's say, the Z, make them a little bit longer in the Z, like that. Okay, sure. So that's sub-D. Unreal Engine doesn't understand sub-D, so we'll need to do a little bit of tweaking here. Sub-D, reference it in. Extract sub-D control polygon, like that. And use Catmull-Clark subdivision on it, like that. With three levels. Okay, let's lock the sub-D geometry here, and let's bake out the mesh. And that's it. Honestly, we don't need this script. This is just to create the mesh. which we can export. And we can export it as, I'll just use the same file, ghbox, and I'll just overwrite it with my new cool and improved box. Once that is done, I'll just delete it here. By the way, obj, right? Don't forget. I'll go back to, that is not it. Where is it? There it is. I'll go back here, and where it says ghbox static mesh, I'll right click and choose to re-import, and it just changes it to my new object, right? Here as well. YouTube box Excel, I can re-import this too, press play, and really hope that it's not gonna spawn inside of my character as it just did. Okay, gotcha. Okay, we need to tweak a few things. Well, first of all, the diffuse color here, I don't feel like black color is that great, so I'm just going to I just double clicked on the diffuse 0, right, on the material. And here, when I select this param tab here, I can change the default value of it from black to, let's say, medium gray, something like that. Hit save, hit close. It's gonna just be a little bit brighter, just gonna be a little bit more nice. Okay, now let's go back, and actually instead of working with it as a what am I trying to say? Instead of working with it, working with its size, maybe we should work with the placement of the grid. So let's look at the grid first. Right here. Yeah, okay, so it's mostly the density that is very, very high. So we do need to change the unlock. We do need to change the size of this. So I'll just scale around 0 base point by half, 0.5. Maybe even less. Scale around 0 base point by 5 times, 0 to 0.2. And here, let's do undo a few times so that we get back the Catmull-Clark subdivision. Bake this out again, default, hit OK. We will get this mesh, right? There's the sub-D that gets locked, and the mesh. Actually, you can even reference in the mesh here instead of the box, set one mesh, so that you can see how it's, apologies, how it's gonna look like. But you can also see that it's not the fastest. It's a lot of mesh polygons. Either way, now once it kind of, yeah, updates, we should be able to export. Once it stops lagging, we should be able to export this smaller tile. Export again as ghbox. Yes, okay. Back to not here. Back to here. Re-import ghbox. There we go. Re-import the Excel spreadsheet. Press play. Oh, cool. There it is. We're above it. Ooh, spiky boy. I think this is cool. Okay, I'm gonna leave it here actually. Because you can, I mean, now we're spawning too high. So maybe I should create, if you're spawning too high and you don't want to spawn above them, you can go in here, quickly add to the project, right? You go in here and is it point player start? There we go. Under basic, there is player start, like that. And you can specify where the player starts by just selecting location. So I'll just say 0, 0, and I will just move everything down. Oh, that's already an intersection, so something like that. Press play. I think now we will spawn underneath, yeah, underneath the canopy. Our little tubes. Oh, by the way, notice how it's not lagging? We're at 100 frames per second with all of these meshes. I can even increase it further, but the problem with me increasing it further is that it's gonna be freaking out here. So I might re-reference the box, which also needs to be scaled to be smaller. Set one mesh. And let's just wait. If we change this from 100 to 200, it's gonna be 4 times more, right? So let's do 200. Why the hell not? It's only going to move the box here, but since we have the cross referenced in our Unreal Engine file, it's gonna use the cross for the Unreal Engine. In terms of yeah, it's done. Well, no, never mind. It's now kind of calculating. Give it some time. Oops. Okay, now it's alive. In Unreal Engine, I just re-import the Excel spreadsheet. I press play, and then I pray. We can even check with Task Manager, performance, how much RAM, how much CPU, how much everything it's eating. So CPU is not getting hit that hard. RAM is barely above 15, almost reaching 16 gigabytes. GPU, okay, GPU memory is, yeah, it's eating it. But we're still at kind of 25-ish. Oh, that's nice. That looks sweet. We're at 25 frames per second. So it seems to be a-okay. And then if you want the character to be spawning above, you just move it above. Press play again. It's gonna load in. That's it. That is it. We are done. We are done with this first part. This is, of course, the setup process, so it's not as interesting as what it's gonna be. Spiky mountain. We're getting stuck in between the spikes. So it's not as interesting what's gonna be in the future videos, but hope this one is kind of gets you excited. Yeah. I'll see you in the next one later. Oh, and by the way, forgot to mention, Patreon supporters get the script and get the Unreal Engine file for free. Well, not for free because they're supporting, but consider becoming a Patreon supporter. Also, we have a Discord server, so you'll be able to kind of get in touch with me that way as well. All right, now we're done. Okay, bye.